The idea with the magnesium-based cements is you start with a magnesium silicate as opposed to a magnesium carbonate. So when you're doing the processing, there's not that elemental CO2 that's going to come off. So we ran the numbers and it was like, oh, this is really interesting. And then COVID hit, and I remember we were at the pub and it was like £2 a pint because they had to try and empty the barrels before they shut for however many months it was that summer. So £2 a pint, and we get chatting and we go, yeah, let's do this. This is going to be great. It's like when you're talking to your mates about starting a band or something. It's like, oh, we should buy a pub. It was exactly one of those conversations. Yeah, we should just do this. So the cement emissions can be broken down into sort of two main sources. So you need to do something about the other 50% of the CO2. My personal opinion is that if you've got this essentially now high purity resource, not to just pump it underground and do something with it. To say you're not going to use cement is laughable, I think. Like, you have to keep using cement.
We could do this and we could do that and we could do the other, but would that have come from somebody that's already within the industry? I understand there is a chemical element to concrete.
Yeah, it's about 3, I think, actually.
But how did you get into the construction industry?
Yeah, so that's really interesting because definitely early doors, going from chemistry to material science is an easy jump in essence. It's just a subset of chemistry writ large. And when I was looking at the PhD application, it just seemed like interesting chemistry. So fine. And then really the transition into the industry side of things happened post-startup, which I suppose we'll get into at some point. It was me and a friend who was also doing a PhD. We were chatting about our work and realised that there was some overlap that didn't really fit into either of our PhDs. So our academic supervisors said, oh, you can do a patent instead of a paper, or not put it into your PhDs or whatever. So you go, yeah, okay, fine. And then you do the patent and the university says, well, do you want to license the patent as part of a startup? And you go, sure, why not? And then you've got a startup, and then you get some titans of industry involved. Mike Cook, Dr. Mike Cook, he's like an iStruct gold medal winner, and he's designed all these buildings in London, and he happens to be a visiting lecturer at Imperial. He does the creative design course, and he and Sam are good friends, and he got on board, and all of a sudden doors start opening and people ask questions, and that was my big introduction to industry. Before you know it, you're talking to architects and structural engineers, and a side of construction that I personally had no experience in whatsoever. Sammy's a structural engineer, so he feels a bit more at home in that space, I suppose, than me. But that was my introduction to the industry, and it's been wild, frankly. I think you go from just accepting that buildings exist to going, oh my God, I know the people that build these. And that's fascinating. It's an utterly fascinating world.
So talk to me about how you came together then with your colleague.
Yeah.
What it was that you were studying, what he was studying, who he is, a bit of background about him. That would be great for
absolutely. So, I mean, Sammy in and of himself, he's a whip-sharp structural engineer. Studied at Cambridge, went to Imperial to do his PhD, and he was working on quite a, I suppose at the time, novel, but nowadays, 3, 4, 5 years hence, is becoming a more established idea, is ternary blended cements. So where you replace it with, you've got your cement and then you've got blast furnace slag and limestone. So 3-component system, which is interesting. And he was just looking at that sort of side of things. But normal cement with supplementary cementitious materials involved. And then my work was more novel than that. It was magnesium-based cements, which are, as opposed to calcium, which is traditional for Portland cement. Interesting science, but less industry backing, if you want. There's something for future. Yeah.
What's the benefit then of magnesium-based cements?
Well, I mean, it depends, really. It depends where you get your magnesium from. So the issue with Portland cement and the emissions associated with it is that the calcium comes from limestone, which is calcium carbonate. So you roast that, essentially, which is high energy, and all of the CO2 comes off from the carbonate bit of the mineral. The idea with the magnesium-based cements is you start with a magnesium silicate as opposed to a magnesium carbonate. So when you're doing the processing, there's not that elemental CO2 that's going to come off. So it's inherently, ideally, going to be a lower carbon solution. So you have magnesium oxides derived from magnesium silicates, is what it's always referred to as in papers. So I was taking the magnesium silicate, turning it into magnesium oxide and silica, and this silica, Sam was just like, that's just exactly like the SEMs that I use. You could put that in normal concrete if you wanted to. I was like, normal concrete? What do you... I had no idea what he's talking about. And then you can do that, so you're partially replacing some of the cement, but then you're left with the magnesium component, which you can then carbonate with CO2 from the atmosphere or CO2 from a cement kiln. So you've got this sort of two-pronged attack where you're doing partial cement replacement and CO2 capture with the magnesium. So we ran the numbers, and it was like, oh, this is really interesting. And then it was, then COVID hit, and I remember we were at the pub, and it was like £2 a pint because they had to try and empty the barrels before they shut for however many months it was that summer.
That's a good deal.
Yeah, it was a good deal. It was a good deal. So £2 a pint, and we get chatting, and we go, yeah, let's do this. Let's do it. This is going to be great. It's like when you're talking to your mates about starting a band or something. It's like, oh, we should buy a pub. It was exactly one of those conversations. Yeah, we should just do this. Yeah, and it's just spun on from there. Like I said, there are just these steps that, while you might not have any intent on doing them in the first place, they're just there, and you just progressively go through with them and end up doing all sorts of things with the idea. Really, it's been really exciting.
So break this down here for me. So I understand that cement creates CO2. I understand that it's the production of the cement that and how it go and how all of the elements go together. That's what creates the CO2.
Yeah.
But what I don't understand is, how is it that this cement then can be like zero carbon? How can you create cement that now does not produce any CO2 at all?
Yeah, great question, really. So the cement emissions can be broken down into sort of two main sources. One is the fact that the kiln that it's made in is at 1450 degrees or something, and that's fired by fuel. They want to electrify them, but it's difficult to get up to temperature with electricity. So at the moment, they are just fired with fuel.
So I'm just going to hang on this bit for a second. So when you say difficult to get up to temperature, do you mean it's impossible at the moment, but the hope is that in the future it's going to be possible?
I 100% think that. I mean, you see them now. Electrified kilns do exist. They're just not commonplace, and they're expensive. So in developing parts of the world, they're not going to splash out on an electric kiln. That's just, it's not on the cards. So you've got, it's about a 50-50 split here. So you've got about 50% of your emissions coming from the kiln fuel itself. And then the other 50% comes from, like I said, the limestone. So the two main ingredients in cement is limestone and clay. You have calcium carbonate and silica and aluminium oxide. And they go into the kiln, and the first thing that happens at lower temperatures, that sort of 500 degrees, all that CO2 comes off. So that's the other 50% of your emissions. Mm-hmm. And then as the cement goes through the kiln, it sort of melts. It doesn't quite turn into a liquid, but you get the calcium reacting with the silicon and the aluminium to form the cementitious phases, your A-lights and your B-lights, which then come out of the kiln rapidly cooled. So they're sort of trapped in this high energy state, which means that when you then add water, they can set, is essentially the principle. So it's two sources of CO2 for cement. It's the limestone and then the fuel from the kiln.
And so, not wanting to kind of give away any secrets or anything like that,
yeah.
How is it then that you can remove that second 50% of that CO2?
Well, that's exactly the point, right? So even in a perfect world where you have fully electrified kilns and a perfectly green grid, you would still have 50% of your cement emissions anyway. So if cement production were to double, then you would have achieved nothing by electrifying the kilns, basically. So you need to do something about the other 50% of the CO2. And that other something is carbon capture, one way or the other. So I have my views on the best way to do the carbon capture. Yeah. Other people have views on how to do the carbon capture. But some way you've got to take the flue gas, the gas that comes off in the kiln, you've got to scrub it, get the CO2 out, and then do something with it. So some people want to purify it down and pump it underground into deep sea storage or saline aquifers or enhanced oil recovery. And then my personal opinion is that if you've got this essentially now high purity resource, not to just pump it underground and do something with it. So you have carbon capture and storage, which people talk about, and then you've got carbon capture utilization / storage. And that utilization is taking that CO2 and not thinking of it as a waste. It's now a raw material again. So you can use that as a secondary material that you can use to turn into other things. So for us, we turn it into bricks or brick alternatives, plasterboard alternatives, things like that. So it goes back into the construction industry. So there's a nice circular element to that.
I love that. So what is it with Sam Draper that you're doing then to build upon this? No pun intended.
It's difficult to avoid things like concrete and foundational and all of these things when you're talking about it. There's puns galore.
So what is it that you're doing then to build upon this, so that it becomes commonplace within the construction industry?
I think what we're really trying to do, I mean, it sounds obvious, but it's de-risk and make it as easy as possible to implement. Yeah. So I think there's a lot of work going on in universities and in academia, which is great and exciting and could be impactful and all of these things. But there is, I find on occasion, a bit of a lack of communication between academia and industry, where the idea can be great, but industry go, oh, it's not really implementable for us for X, Y, and Z reasons. Like it's good science, but it's not. We just can't use it. A prime example is alkali activated materials, which is 100% blast furnace slag, and then you activate it with sodium hydroxide or potassium hydroxide, something like that. And great, they're interesting. I mean, the slag issues we can come on to, but the problem is contractors, the people that are actually building, if you've got a cement wagon that has just had geopolymer concrete in it and you try and put normal concrete in it, flash set, and you can't use it. So you can't use the wagon. So if you want to use geopolymer concrete, you have to use it at the start of the day or the end of the day so that it doesn't contaminate the rest of the concrete. And it's these sort of practical issues that you have to address those with the technology before you even bother doing the research. Because if they can't implement it, they can't implement it for whatever reason, bottom line or contractor programs or whatever it is, these really practical issues. So for us, that was our first port of call, really. It was go and talk to people and say, what is it about a material or an idea or a process that means that you will be able to use it? It's like, well, the guys on the ground are going to have to do everything the same. It's going to still have to set in 2 days. It's still going to, there's all of these things that are just practical, not scientific, just purely the guys actually doing the building. Yeah, so I think that was our first avenue to go down to try and get this to work beyond the actual science itself. And then it's things like, how do you make it efficient? How do you make it low energy? Because a lot of tech will just say, oh yeah, we'll just imagine that it's a green grid, so it doesn't matter how much electricity we use. But it's like, yeah, it's a nice idea, but that's not really how it's going to work. You can't just say we'll just use wind power for everything. It's just not on the cards yet. So yeah, practical issues need to be resolved immediately. I think that was our way of going about things.
I think that the point that you've raised there, I think that will be a conversation in a couple of years to come, which is demand. So just because the electricity has been generated from a renewable source doesn't mean to say that we've got an infinite draw upon it at the moment. We've not got anything that we're using with infinite, because it's not always windy and it's not always sunny.
Exactly. And how do you prioritize where to use that renewable energy? Maybe we're better off using it to power our homes. Maybe we're better off using it to charge electric cars because then they're not using petrol. So while it's not infinite, we're going to have to make some decisions about how you use it, basically. Yeah.
So the statistics say that the primary contributor, one of the biggest contributors to CO2, is actually the built environment. It's not cars.
No.
Despite what people are saying, it's not airplanes.
Yep.
Flight. I think that's 2%. I think is.
Yeah, that's like 1.9 versus 8% for cement. And not even including steel and actually building. So yeah, absolutely. Yeah, it's a huge sector.
So absolutely massive. Is the ambition and the desire completely to shift from the current concrete and cement to what you have developed and invented?
So, short answer, no, absolutely not. So, for starters, what we do at Seratech is just partial replacement. So even in an ideal world, we'd be at 0% emissions from cement, but you're still manufacturing 70% of the cement that you were beforehand. So, you're not changing anything really in that respect. I think there's a couple of reasons why you don't want to shift away from Portland cement. One is that there are literally billions of pounds worth of infrastructure that is already in place for using cement. There is 200 years of experience in using cement, and it's a fantastic material. Like, nothing comes close to ease of use, durability, low cost. To say you're not going to use cement is laughable, I think. Like, you have to keep using cement. There was a really interesting paper, I think it was Karen Scrivener, Sam always talks about it, which talks about, because of the scale of the built environment, there's a lot of stuff that needs to be built. The thing that you're building out of, there also needs to be a lot of it. And when you look at the stuff that makes up the Earth, the actual chemical elements that make up the Earth, you've got calcium, silicon, aluminium, iron, magnesium.
In that order?
Maybe not in that order. Don't quote me on that. Silicon is at the top of that. Silicon dioxide thing. That's what all rocks are made out of. So if you're going to build the built environment, you've got 5 elements to play with. 5, 6, but I've almost certainly forgotten one. But that's it, So there's not actually that many degrees of freedom when it comes to this. You can't suddenly invent a totally new element, it's just not possible. So you're going to have to stick in your limits. So I don't think we want to move away from cement. I don't see industry moving away from cement. I think it would be a bad idea to move away from cement. It served us so well in terms of buildings. It's just finding out how to decarbonize it. That's the thing. Don't move away from cement. Just find a way to use it sustainably, I think.
Okay. What do you hope then for the future of the built environment now that this has been discovered?
Well, I mean, not just our idea being discovered. I think there's a lot of stuff that's happening that's really interesting. I mean, for starters, like I say, moving towards renewable energy is a good thing. Moving towards electric arc furnaces for steel as opposed to blast furnaces. So I don't really work with steel, but that to me seems like a no-brainer. And then I think what we really need is a paradigm shift in how people think about how processes sit with other processes. It's I mean, the term circular economy gets thrown around all the time, but the integration between steel and cement, so the byproduct of steel making being blast furnace slag, which is a perfect supplementary material, so it's an ecosystem that works really nicely. And I think whatever it is that we decide to do to try and tackle the emissions associated with the built environment, it needs to be part of an ecosystem where you can't just decide all of a sudden, oh yeah, we're going to use billions of tons of X material and produce another billion tons of waste, because you're just swapping one problem for another. So it's having a holistic approach to how the processes fit with one another that I think is going to have to be key. If someone just says, oh yeah, we've got an idea, but it does X, Y, and Z, you go, well, it's just not going to work on a big scale. You're just creating another problem that in another 50 years time, somebody else is going to go, oh, we shouldn't have done that.
Yeah.
That was a bad idea. I don't know why, you know?
So, and that principle feels like it rhymes to me with batteries.
Yeah.
And the reason it feels that way is because of the material lithium. So you need lithium.
For batteries, yeah.
Batteries, right?
Yeah. I mean, I think it's interesting. I mean, I did see a presentation years ago about some newfangled batteries that were coming that were less reliant on these rare earth elements and things like lithium, because obviously the consumption of raw materials, the mining of lithium is the real issue there. And I think because it doesn't happen on home soil, people turn their eyes away from how bad it can be.
Yeah.
And there are some awful mining practices, I think, out there that we did away with 200 years ago, but still let happen because it's happening over there, sort of thing. And I would love to see people taking that exact same approach. So yeah, like I said, it's not just the construction industry that needs to be circular and holistic. Any industry, any new process that is invented to do something, any new battery that's invented, because we're going to need new batteries, whatever they decide to do, they have to be clever about the byproducts. They have to be clever about the waste. They have to, I'm not saying you have to valorize it to make it an economically favorable process, but do something with it, because you've spent the time getting it out of the ground. It's out of the ground now. There will be something you can do with it, sort of thing, Yeah, but absolutely. Any new thing, I think people have to think more broadly about where it sits in the world.
Talk to me about a project that you've been working on that you feel can be adopted, or you hope is going to be adopted more widely than what it is at the moment?
I think the first thing that comes to mind is we did a tiny wall, because at the moment it's hard for us to make our cement because we're based in a lab and it's me stirring pots by hand and stuff, so it's difficult to make a lot of this stuff. But we made 100 or so bricks to make a wall for London Design Festival. There was something that it was for. And they weren't mortared together. We had holes in the bricks and then just vertical. It was supposed to be bamboo, but it ended up just being, I think it was old bits of scaffolding running through the bricks, sort of thing. And they're on a base. And it just means that the entire thing is totally demountable and you can rebuild it however you like. And so essentially what I'm talking about is modular construction, which we are seeing more and more of. But that's a great example of something that, I mean, I don't see why you can't have a zero carbon concrete that is also used in modular construction. It's not that you can only do one or the other. You can definitely do both. And I definitely saw that as part of it, just the way it's totally move aroundable. So we had it as a wall, then we had it as a bench, then we had it as a table at Future Build that we went to later in that year. And that principle is so easy to implement. I think that's a great thing that I think people will see more and more of. And it doesn't have to be, I think people think modular construction, they think, when people stack shipping containers on top of each other, you go, it's a bit one-dimensional, it's a bit boring. It's like, it doesn't have to be like that though, does it? I think engineers and designers putting more effort into that sort of a spin, not that they don't already, of course, but absolutely, I think that will be a thing that I would love to see more of.
Do you think the future of that lies with people similar to yourself that have just come into the industry?
I hope not, or else we're in real trouble. I think it's up to people. I know actually. So Mike Cook, the guy that we work with, he works with a lot of students doing his course, and he always talks to us about how do we mold the next generation of engineers to think differently to how I thought, sort of thing. And I think that it all begins in the classroom. Sounds a bit cliche, I suppose, but if you instill these ideas in them when they're learning what it is to be an engineer, then just by the nature of things, when they get into the real world and start engineering and start designing, then it's going to be at the forefront of their mind. I mean, you see it already with people being conscious about sustainability when they're building buildings. I just don't think they're equipped with any tools to do anything about it. They still have to use concrete and steel. And I'm almost certain that most of these engineers that learn engineering recently and have that in the forefront of their mind probably feel quite bad and conflicted about that. I'm almost certain that they do. But short of specifying a concrete with a higher percentage of slag in it, which actually doesn't do anything, there's not a lot that they can do. They can try and minimize materials, but labor cost is so expensive that people tend to not even bother doing that. You see some of these old buildings where they have these vaulted ceilings, like a dome, and that uses the compressive strength of a material to its advantage, so you can get away with using less material. But I suppose they're a complicated structure, and because labour is so expensive compared to raw materials, nowadays what we do is go, no, we don't need that, we'll just have a nice thick concrete slab, which it doesn't need to be there. So that's the thing. I think people will naturally tend towards more sustainable ideas I haven't had. There's more ideas out there, almost certainly.
Definitely.
Yeah, definitely. Loads.
Definitely. So I guess the thing that I've noticed from having my own consultancy and also from doing the podcast is that it seems as though the system is designed to protect the system.
Yeah, I mean, it is.
So that's why I asked the question about someone that's outside of the industry coming in, because of their mind and the thought process. They've not been brought up in the system or taught by the system, because the system, and hopefully this makes sense, is created and generated to protect the system. So unconsciously, it's perpetuating itself, and it's only someone coming in with why are we doing it this way? Or I've got a bonkers idea, let me share this. And they're doing it with openness and humility, as opposed to when you're in the system, your credibility is on the line, which is down to the way that you're viewed by other people, and so on and so on and so on, which keeps you in the system.
Yeah, that's a really interesting point, because I definitely am not in that system, I suppose. And
I see that from you, and it's come through in your energy, and it's come through in the way that you present yourself. You're like, look, I'm almost apologetic. I feel like a charlatan here.
Yeah.
But actually what I've happened upon, we could do this and we could do that and we could do the other. But would that have come from somebody that's already within the industry? Because this was a conversation that you had on a £2 pint.
£2 pints.
A pub.
Yeah, it's really interesting. I think the thing that you always have to remember is that this industry is based on really old ideas, but they're ideas that work. And like you say, people have a reputation on the line. Can you imagine the situation where somebody builds a hospital that then 6 months later collapses?
Absolutely.
Awful.
Terrible.
So you can understand why people are apprehensive to try new things when we have something that works. That being said, I do think that there is a lot of the way that the construction industry is segmented into all of these different parts. You've got from upstream with your actual cement manufacturers all the way through the designers and the contractors and the builders, and going all the way down. And a lot of it is to do with risk management and who is responsible for what element here, there, what element there. Where does the buck stop, essentially? So you try and have a conversation with somebody and say, well, do you want to try this? And they go, well, it's not really our decision. We can't do that. So you take it to the next step up, and then you say, well, and they say no for the same sort of reasons. And it can be difficult to sort of get a foot in the door, basically, because it does seem quite complicated and convoluted, and it's not exactly Kafkaesque, but there's a lot to it and a lot of moving parts, and that doesn't make it an easy industry to permeate with a new idea, I think, for sure. And yeah, like you say, I don't think people working at cement plants are the people that are going to come up with ideas of how to make cement plants obsolete, for obvious reasons, I suppose. No, I know I said I don't want to make cement plants obsolete, and I don't, but there's definitely a going against yourself. It's not the best way to breed innovation. And it's funny, I have a friend who's a structural engineer, and he was at a dinner. It was a dinner or a round table or something like that, and one of these industry discussions, and there was a global head of R&D for one of the cement companies. I won't name names, but he was saying, yeah, we've got stuff in the pipeline, low carbon alternatives that are ready to be deployed. And the structural engineer said, tell us what they are, because we need to know what the properties are so we can design with them. We need to know so that we can start implementing these sorts of, like, you don't have to deploy them now, we get that, fine, but you at least need to tell us what your direction is so that the people downstream of you can start demanding it. Because this is the thing, it's supply and demand. If the cement industry don't tell people that what they're doing, then they don't think there's anything available, so they don't demand it, so the cement industry don't supply it. And if they don't supply, and all of a sudden you've got this little circle of absolute no change. So that sort of thing, yeah, I do find that frustrating. But it is what it is, and that is to paint with a really broad brush. I will say there are cement plants that are implementing all sorts of really interesting things. There's the lilac and all of these like vertical kilns that produce pure CO2 that make it easier to do that. There is stuff, there is movement, but for sure the system that is in place does not help with that movement. I 100% agree.
So I think that you've just confirmed to me what I already think, is that it's going to take somebody that's outside of that system to come in and say, no, actually, this is what we're going to do. Because when you give that example about that cement firm that is working on something, the way that you presented it to me sounded as though it would make a difference.
Yeah.
Financially, they're thinking, well, we've already got the cash cow.
Yep.
This is now down to money. It's not down to anything else.
Oh, absolutely.
We just need to keep pumping the money out because we need to keep the shareholders happy.
Yeah.
And we need to keep that reputation of our jobs. It's got nothing to do with, are we concerned about the hospital falling down if we use this new product?
Yeah, well, I mean, absolutely. I think there's definitely going to be a monetary component to all of these things, which, maybe won't be the case for long. You have things like CBAM being introduced where the carbon border adjustment management thing. So if something comes abroad and it's got high CO2 associated with it, there's taxed. Essentially, it's a carbon tariff, basically. I think that's rolling out in 2027. So cement imported from abroad that's got high carbon emissions on it, that will start costing a lot more. And that's when people will start going, oh, geez, this carbon stuff is really costing us. It's really hurting the bottom line. So then you've got that monetary barrier sort of is starting to give way, I think. And I hope to see that happen, really.
Do you know, I think the thing at the heart of me is I'm looking for that disruptor to come in and say, right, we've created this. We're going to take on the big boys. I use this example all the time and I need to think of a different one. But it's like the Netflix coming in to take on the Blockbuster.
Yeah.
That then turns into, Blockbusters like we've gone.
Yeah.
Or we thinking we've just been so far behind, so focused on let's keep the system so that we can keep the money, that actually now we've lost the money, because the way to innovate effectively is to cannibalize yourself. Yeah, you need to reinvent yourself.
Yeah, you've got to be happy to lose something.
By destroying yourself.
Yeah, 100%. Yeah, I mean, I would love to see it. But like I said, I mean, at the core, we're still going to be using limestone and clay, because why would we not? We're still going to need these kilns. We're still going to need to do something that's very similar. So I suppose I would love to see something that disruptive come in and really make a change. But I mean, that in and of itself, being a disruptor, is a barrier to implementing that change. I suppose our ideology is to be less disruptive and just sort of sneak in there. Sneak in there without anyone knowing, and then got you. You're decarbonised. Didn't even see it happen. Now it's happened. Carry on as you were.
So if someone's listening to this podcast and they've got a deep pocket that's looking to fund something to really make a difference, I'm talking like really, really deep pockets.
Really deep, yeah. They need to be deep. It's hard tech, It's not an app. You need money to build these things.
What would you do with the resources of those deep pockets?
Yeah, well, I mean, it's a timely question, actually. So we're right in the middle. I suppose Seratech is right in the middle of our seed funding round. So we're trying to raise about £4 million. And you've got the wrong man on here, because Sam does all of the business side of all of this, basically. So he's pitching to investors all the time. And we've just started that. And the idea is to build, a really ugly shipping container pilot plant that essentially produces, or I suppose captures, it's about 1,000 tons a year CO2. So magnesium silicate in one end, zero carbon slag alternative out the other. And that's what we want to do, because you can't convince industry with 100 bricks. I loved making them. They're really pretty. Most of them didn't fall apart. But that's not what people want to see. They want to see 3x3 meter slab that sets in 2 hours and doesn't crack. So you need to be able to make decent amounts of material. And it's tough if you're not using something that already exists. You get a lot of tech out there that's based on slag or whatever, and you just ring someone up and say, yeah, can I have 10 tons of it. Fine. But if you're actually trying to innovate a brand new sort of foundational industry, creating your own material, then you need money to build this facility to actually do it. But that's the idea. Build a pilot plant, churn out some material, make a nice foundational slab, show people that it works, do all of the testing, and then it's about choosing the right projects to put it in. So we've spoken to people about that sort of thing. There are some really interesting ones.